So when we are graphing absolute value inequalities, we're going to rely a lot on our transformations to show us how that graph is moving. And then just like with when we graph lines or when we graph parabolas, if those are inequalities, we have to shade our graph depending on the inequality that we're given. So let's start with this first inequality. So this is just our parent function absolute value. So that means there are no transformations here. Our graph isn't moving around the coordinate grid. We have no transformations. So that means it's going to start at 0, 0. And then absolute value graphs just go up 1 over 1 each direction, so that they create that V shape that we're used to seeing. Now, with inequalities, before we draw our lines, we do have to pay attention to what kind of inequality we're given. So remember, if there is an equal to bar, like we have here, that means it is a solid line. But if there was no equal to bar, then we would have a dashed line. So make sure you're paying attention to what kind of what kind of inequality you're given. So we know this is going to be a solid line, so we'll draw that out, put our arrows on the ends. Kind of straighten that line out, put our arrows on the ends. And once we have our graph drawn, now we have to go back and shade. So when we are shading, now we're paying attention to, is it greater than or is it less than? So remember, when it's open like that, that is a greater than sign. What that's telling us is that we want to shade all the y values that are greater than our graph. And when y values are greater than something, that means they are increasing, so they are becoming more positive. So we want to shade going up the y-axis. So in this case, that would mean shading everywhere that is inside our absolute value graph. So I'll say that again. When we are shading greater than, a greater than inequality, that means our y values are increasing, they're getting more positive. So that means we are shading going up the y-axis, and this time the increasing piece of the y-axis sat inside our absolute value graph. We can also double check this by picking an ordered pair that is sitting anywhere on the graph. It doesn't matter where it is. So for example, let's say I chose the point 4, 0 as my test point. I want to see if this point is going to be in my shaded region. So I'm going to use 4, 0. So that means I'm just going to take that point and I'm going to plug it into the original function that I was given. So instead of y is greater than or equal to the absolute value of x, we're going to plug in 0 for y. So we have 0 is greater than or equal to, and then we'll plug in 4 for x. The absolute value of 4 is just 4, so 0 is greater than or equal to 4. That is a false statement. 0 is not a bigger number than 4 is. So that means I will not shade where the point 4, 0 is located. So that means I'm not going to shade going down outside of the absolute value graph. I'll be shading inside. So that's another way to double check that you've shaded the correct direction. Pick a point. If you get a true statement, then you shade toward that point. If you get a false statement like we did here, then we shade away from it, the way we shaded inside the V and not outside where that point 4, 0 was. Let's try another one. Example 2. Again, let's talk about our transformations first. So this time we do have a transformation inside the absolute value bars. So that tells us that our graph is moving to the right 3. It's inside, so we know it's horizontal movement. And then we do the opposite when it's inside, so that means we're going to the right 3. So instead of our graph starting at 0, 0, the way it did on the parent function graph over here, we are going to shift that graph right 3 and start it at 3, 0. There are no stretches or shrinks here, so that means we are still continuing the pattern of going up 1, out 1 in both directions. So we'll just plot a few points to see what that's going to look like. Now, let's pay attention to the inequality we're given. We do not have an equal to bar this time. So that means that this will be a dashed line. Whoops. Let's get that down a minute. So instead of a solid line through those points, we're just going to leave some spaces to represent that dashed line. Just like that. All right. Now we need to figure out where to shade. So going back to that inequality, this time our inequality is facing the opposite direction, so that is a less than sign. When we are given a less than symbol, that's telling us that all the y values that are part of our solution are going to be smaller than or less than our graph. Anytime y values are smaller, that means they're going down the y-axis, they're getting more negative. So everything down the y-axis would be right here. So that means we're going to shade everywhere outside of that absolute value v graph this time. This time going down the y-axis was outside the v, so we had to shade everywhere outside that v. But let's just double check ourselves and make sure we shaded the correct direction. So I'm going to choose a point, and I'm just going to make it easy on myself and choose the point 0, 0. That's always a nice point to test as long as it's not on the v piece of the graph itself. So we're going to test 0, 0 this time. So we're going to plug in 0 for y and a 0 in for x. So 0 minus 3 is a negative 3. The absolute value of negative 3 is just 3. And 0 is less than 3. So that is a true statement this time. So that tells us we shaded the correct direction, that the point 0, 0 should be in our shaded region, which it is right here, surrounded by that green shading. Let's go ahead and talk about vertex and minimum and maximum. Just like on a parabola, the vertex is always the point at the very center of the graph. So in this case, that point is right here at 3, 0, and that resulted from our transformation of shifting it right. And then to determine if that vertex is a minimum or maximum, remember maximum is the very highest point on your graph, minimum is the very lowest. So in this case, that vertex is sitting at the very bottom of the V, so that means we have a minimum.